Hi, everyone. You're welcome. You're welcome. You're welcome to the meeting today. Um, this is YPC and a young professional community of the ASABE. And basically, today we'll be talking about something really very important. And we have an expert in that area coming to speak to us. That's Andres. I would invite Derek. So Derek would do an introduction of Andres, who is, and as he would be introducing the speaker, feel free to drop, I mean, your name, where you're connecting from on the chat if you like. And throughout the meeting as well, as Andres will be speaking, you would have the privilege of asking questions. So you can drop those questions in the chat box. And we'd have 15 minutes after the meeting to get to questioning. So let me invite Derek now to introduce Andres.
Okay, hi everyone. Yeah, I think you can all hear me.
Yeah, we can.
Perfect, yes. So I am Derek Halose and I am from McGill University in Canada, and I am a subcommittee member for the technical subcommittee for ASABE YPC. So today we have in our midst Dr. Andres Ferreyra, who is an industry standards and collaborations lead for Syngenta. So Syngenta is a world-renowned company into farming and seed business that tries to provide farmers on a way to grow nutritional food while also saving the environment. And he also chairs the ISO Technical Committee 347 that is based on data-driven agricultural systems, and he's also part of the ISO International Workshop Agreement 47 that um, came with the reference architecture for data-driven agricultural systems. And Dr. Ferreyra has also developed technologies for agri-food and natural resource systems for over 30 years experience, and has also participated in the international data standards community since 2010. And he has a very catchy word. He always says, I care with a sense of urgency about people, food waste, culture, and living sustainably in nature. So join me in inviting Dr. Andres Ferreira to give us a wonderful talk on data-driven ideas in food systems.
Thank you very much, Derek. And I'll take a moment here to shrink my screen so I can share my screen. Can you see my PowerPoint?
Yeah.
Okay,
yes.
Good. Okay, I need one more moment to shrink things a little bit better so I can see questions that come in, and then we'll get started, hopefully right at 5 past the hour. Okay. All right, this is great. Okay, and then let's make sure I can see the chat. Okay, this is perfect. Well, thank you very much for allowing me to speak to you today. We're going to cover a lot of material. I don't expect to get to cover the whole thing. There will be some slides that we might skip over, but I'll certainly make this material available to you so that you can look at it offline and ask me questions over email and so forth. Right. So what we're going to talk about is in the context of the UN Sustainable Development Goals, which are a set of very powerful ideas that we need to work towards with a sense of urgency if we expect to have an inhabitable planet for ourselves and our children. So let's start talking about me. as a precursor to the rest. I'm originally from Argentina. I've been living in the US for about 25 years. I'm originally an electric and electronic engineer. Got a master's in agrometeorology and a Ph.D. from the University of Florida in agricultural and biological engineering. I've been an ASABE member since the year 2000, and I cannot recommend that strongly enough. Like Derek said in his introduction, I care about people, what they eat, why they eat it, and living sustainably within that system. I also like to cook, and you can see my little temple to cast iron there on the right. I'm also a beekeeper. At this time of year, I can tell you our bees are hangry, and working with them is quite difficult because they are furious. Things that I've done. I've been around for a very long time. And at first, I worked in industrial automation with remote sensing. And a few years into my career, I discovered crop simulation modeling when I was working on my master's degree in agrometeorology. And I thought that was really an incredible thing and that had enormous power. I moved to the US in 1999, like I said, and I kept working on those things during my PhD. Along the way, I realized that it was important to enable the use of these models at scale because using them has a series of problems having to deal with data and so forth. I started working for a company called AgConnections in 2004, and there I worked with Farm Management Information Systems, so this FMIS acronym, and also looking to optimize cropping systems and like irrigation management tools and so forth. That quickly started involving machine and IoT interoperability, so bringing in data from harvesters and planters and sprayers and weather stations and so forth to do things with those data that could help drive decisions. And since about 2010, as recommended by John Deere, who was one of our business partners, I got involved in standards work. And that has evolved until today. I chair things like the ISO Technical Committee 347 and the International Workshop Agreement 47. We'll talk more about those things. So near the end of this line, I started working for Syngenta, which was AgConnections' biggest customer, and bought the company. And I have a global role in Syngenta now. For quite some time, that role involved, for about 4 years, that role involved architecting and being the product manager of very large machine data and IoT data management infrastructure. But from the beginning of this year, I just work with standards. Along the way, I've tried to focus on practical problems that range from making an early warning system to detect forest fires with satellite images, to automated irrigation system design, to the kinds of machine and IoT data usability problems that I mentioned, and just helping farmers run their business with data and enable their computing systems to do this. Along the way, spoiler alert, data interoperability is becoming a bigger and bigger problem. We're going to focus on this helping farmers run their businesses with data theme as we go along for the rest of the ride here. So quick story about AgConnections. We provided farmers with the farm management information system, so a software that helps run their operation. And that software helped them solve business problems, like, am I making or losing money? facing a rent increase, can I pay it? Do I need to walk away from it? How do I allocate my land? Can I put my land in should I put the field in a conservation easement? Should I farm it more intensively? So forth. Also, regulatory issues like, am I applying chemicals properly by the label? Sending reports to processors who buy the product and want to make sure that it is produced in accordance with an agreed upon protocol, and so forth. These are the nuts and bolts, the record keeping nuts and bolts of farming, which are often very hard to do at scale and at the individual field level. Doing this involved also aggregating data from many farmers to summarize their use of certain kinds of products, comparing it to program thresholds, and aggregating that over different geographic regions. That's the sort of thing that Syngenta wanted AgConnections to do for them, and to manage the data in accordance with very strict data ethics by design. So enforcing certain boundaries, so Syngenta didn't see some data that was private to the growers and that the growers cared about, that what was shared was specifically what had been agreed upon, and those sorts of things that are very important. Another thing that we did that I led the development of was the creation of a very powerful handheld data entry platform. Back in the day of Windows CE, Pocket PCs, we had growers that had nearly 1,000 fields in those little Pocket PCs, and they could, in a very agile way, capture what they were doing with those fields. We were even able to bring in application data from John Deere equipment and use it for record keeping back in 2007. People are still having problems doing those things today. Why did this work? We were very strict in maintaining what's called product reference data, which meant that the meaning of things was very carefully curated and preserved. We were very strict with the growers' master data, like their field boundaries and what lists of products they were going to use in a given season and things like that. When something was coming back from a machine that we didn't recognize, we forced that the uncertainty be resolved before that record could be brought into the system to keep data quality high and so forth. We respected mass balance. We enabled sending important reference data out to machinery ahead of time. We invested very heavily in a support team that was friendly and capable and helped people solve their problems. And perhaps most important of all, we worked very hard to keep the system simple and focused on the business fundamentals that the grower needed to be successful. And we did this for several years. Now, farm management information systems can start breaking down for a farmer. And in situations where the farmer can be quite frustrated with it. And showing you a little pain scale here on the side, what are the sorts of things that can produce this? Well, one, unmet expectations and frictionless experience. When you think that you're going to digitize things, you say, oh, you know, I'm going to have a lot of more time available because I won't be converting data and wasting so much time in this. Yes, but there's some aspects of this that are hard to scale, and if you don't have a good workflow that can enable it, it's very hard to do it. Also, exchanging data with business partners is quite painful because there aren't standard data packages for different processors and bankers and so forth. Everything is sort of a bespoke data payload that you have to build. That's quite burdensome for a farm management information system to do. reporting is just a huge burden. And yet, although things get difficult for a farmer to do that, and got difficult, just farming itself is getting harder. If you think about what farming and food production entails, there's hundreds of decisions every crop season that have to be made, some of which are very risky. In the past, maybe many of these decisions could be informed by what your family had done over the years prior, right? But now when the world is changing so quickly, there's climate change, supply chain disruption, political instability, and so forth. These decisions have to be increasingly be made based on data, which is not so easy to do, right? Not only that, not only is the context harder, but farmers need to do more than before. When we were using our LandDB software with growers a few years ago, we're tackling fundamental questions about profitability and regulatory and production contract compliance. And a smaller part, maybe 10%, calculating sustainability field prints and things like that. But answering those questions, while necessary, is no longer sufficient because growers are operating under a dwindling base of resources like crop inputs. So you have to make your tools smarter to help with complicated optimization problems. Like if I have so much water or so much fertilizer, or I'm allowed to use so much of this or that chemical, how do I use it best? I mean, you have changes in weather patterns and other climate and supply chain disruptions that require complex data-driven risk management instruments like crop insurance that don't always exist, or that you might need to build together with other people. You have to deal with labor shortages, not just a direct label where there might not be enough people available to harvest your horticultural crop, for example, but also in the lack of advisors at a time when we need them most. Also, tightening margins in the business drives searches for opportunities. There might be government programs, there might be carbon credits, things like that. But many of these are data-driven and require record keeping. And last, but definitely not least, you have a generational problem where the idea of working in agri-food systems isn't, often seen as an aspirational career choice by youth. And this is where you guys come in as a very important piece of this puzzle. Now, it gets worse at scale, right? Because agri-food systems are very data exchange intensive. When you get out of the farm gate and you start looking at the broader picture, right? You've got your crop input manufacturers, the distributors of those crop inputs, the retailers, the growers that those retailers do business with, then the buyers that the producers sell to, then the processors that make the food, the distributors of that food, the retailers of that food, all the way to the dinner plate. Let's call this the primary agri-food supply chain. There's a lot of different actors in it, right? And oftentimes those actors need to keep a traceability, say like one step forward, one step back traceability of what they sold to whom, what they bought from whom, and so forth. Now, it's not just that they're interacting along this line, because many of these actors have advisors that help them make decisions and with whom they need to exchange data. Or they need to interact with test labs that can allow them to quality control the different substances or products that are involved in their processes. There's equipment dealers, there's equipment manufacturers who might have clouds that you go and pull data from, right? Then there's service providers of various sorts, remote sensing data, weather data, financial advisors, insurance providers, and so forth. And of course, pretty much everyone has to provide data to regulators, right? So this is a very complex network in which data is being exchanged and being exchanged inefficiently and with trouble. But the data are being exchanged. Now, if you step aside out of that network for a moment, you've got the smallholders, the small producers worldwide would greatly benefit from being inserted in the system. But how do they fit? They produce about 46%, depending between 30% and 50% of the world's food, depending on who you ask. But they are far more vulnerable. They have less access to a lot of things. And yet we're trying to make all these data exchanges work. But when you try to do that without standards, what you have is multiple data producers, say different machinery manufacturers, different service providers, different weather data providers, and so forth, each one of whom has their own data format, have their own proprietary way of encoding their data and serializing it to files or APIs. Then the consumer of those data is responsible for converting from those different languages that these folks are encoding their data in to whatever they're using internally. Let's call that the Z language, right? And managing these converters right here is a very burdensome process, especially when a lot of farm management information systems companies tend to be small. That produces a lot of pain and suffering. What's the alternative? Well, if we all use the same standardized language, then the burden is spread out quite evenly because both the producers and the consumers agree to send data around in that common format. And that makes things a lot easier. Now, let me go through a few examples for you of that can put this in context. The first one is irrigation schedule. Irrigation water is a very valuable risk management tool, especially in these unstable times where we have droughts, where before we used to have rain and vice versa. Water, though, fresh water is an increasingly scarce resource. And there's techniques for how to use that scarce resource optimally, such as scientific irrigation scheduling. But as you can see in this picture here, the fraction of total ranchers and farmers that use scientific irrigation scheduling over the ones that don't is rather small, right? Which suggests that this irrigation water is being used with less care than the situation calls for. Now, why is that? Is it, because people are villains? No, let's think of what you need in order to implement scientific irrigation scheduling. First, you need what's called observation data. So the observed field conditions, how much soil water you have, what the temperature, evapotranspiration, and so forth are, right? Then you need a decision support tool that can help you turn those inputs and maybe the history of applications into a plan. And then you need to be able to go implement that plan out in the field. So it involves integrating with the sources of the data, and then it involves integrating with the things that would consume the data. For a grower with, say, 32 center pivot systems that has to deal with multiple non-interoperable decision inputs, so different weather providers, these irrigation records that are in their farm management system, soil moisture measurements from another system, and so forth. This ends up becoming an endless copy-paste exercise, which even if it took them, say, 3 minutes per field per day, that's over an hour and a half per day, and with a non-trivial probability of making mistakes. And people end up concluding, I don't have time for this, right? Which was words that we saw earlier when we were talking about the problems of FMIS for growers in general, right? And all this comes back to the poor interoperability where system components just can't talk to one another. So in summary, right, we had that setting, we had that conflict about scaling, scientific irrigation scheduling, the problems, the lack of interoperability, and what would success look like with standards? Well, if all of these things are speaking basically the same language, then we can optimize irrigation scheduling at scale based on sound scientific principles. A very different problem, say one that's common in Western Africa and many other emerging economies. You might have growers that are growing a crop, investing in it, and then when they go to sell it to some processor, they're informed that the price that they thought they were going to get is not the price that they're going to get. And they get some obscure reasons for it. And there's a very high chance that they're being cheated, right? But the factors that form the prices are unclear to them. They lack the information. And therefore, they often settle for reduced prices, like maybe 40 cents on the dollar of what they thought they were going to receive, due to the sunk costs and the lack of alternatives or of information. What would success mediated by standards look like? Well, you'd have tools that would give farmers clear information about the entire value chain and how the prices are formed, and give them access to alternative buyers if the current buyer is not being fair, right? A third example, machine data problem. So you've got an agronomist that's trying to provide precision farming services using on-farm planting, yield, and soil fertility data. Okay, so like classic precision ag services. What's the problem? They spend so much time per acre cleaning and preparing data that the business just isn't sustainable because it's too expensive for customers. You just spend too much time per unit area. Why does this happen? A lack of interoperability. What would success look like? Well, if different manufacturers use the same standard or provide tools that can help you convert among those standards, and the agronomic tools readily accept the standard, then the friction drops, efficiency grows, per hectare prices drop, and the business becomes sustainable, and the services might even become affordable to small growers. Fourth example, human capital mediated extension services. So the possibility of having an extension agent or somebody like that aren't scalable where you have a lot of smallholders. There's just not enough of a national budget to allocate to these services, and not enough trained people to be able to go and individually provide services to the small growers. And yet these small growers need those services more than ever. There's new pests, there's new diseases, there's new stresses that they haven't had experience with before. They need help. So you'd imagine that AI-driven digital tools can enable extending the reach of existing advisors, right? You don't want to replace the advisors, right? But there's some problems for which you can provide a solution with a high level of confidence. And sometimes with not such a high level of confidence. So in the subset of situations where the level of confidence isn't so high, you can pass it on to the agronomist from the app that the grower is interacting with. And then the high level of confidence scenarios just involve only the app. It's a way of extending that reach. A simple example of this is yield estimation. This is something that I've done quite successfully, in fact, where you, with a phone-based tool, provide a way to estimate plant density. Then with that same tool or another tool, you can estimate the kernels per ear, right? And the weight per kernel. And so then you have the components of yield, right? So your plant density times your ears per plant, times your kernels per ear, times your mass per kernel is your yield in mass per area. And you can update that yield estimate over the course of the season. So early in the season, when you're looking at your plant density, you can get an upper bound on what your yield is going to be, right? And as the season goes along, you can refine that estimate to get an estimated yield. So standards would allow you to scale those solutions up so that people could customize them and use them in their particular regions, right? So we just went through 4 quick examples of this. So when you find yourself in a hole, stop digging. What does that mean? Well, our industry has a problem. Our standards just aren't enough to support the data-driven decision-making that we need to solve these modern problems, much less to take on the SDGs. This emerges from the fact that the industry has grown bottom up, and so have its standardization efforts. So ISO, the International Organization for Standardization, realized this some time ago, and they chartered a strategic advisory group for smart farming that I ended up co-chairing. We had about 180 experts from about 20 countries. We had this mission of coming up with a strategic roadmap to guide what we could do better collectively as an industry, and ISO as an international standards organization that has 25,000 standards that it has placed at the service of the Sustainable Development Goals. A key part of the proposed strategy was to create a new permanent home for data standards in this agricultural space. It have to do with helping make data-driven decisions. Right? And this is Technical Committee 347 that I'm the chair of now, right? It's something that the US and Germany handle together, so we lead this jointly. Germany does what's called the Secretariat, and the US, through me, holds the chair. The scope of what we're doing, basically develop and promote standards with the purpose of enabling comprehensive data-driven, multi-objective decision-making in agri-food systems. At the context, there's a typo here. It's just a volatile, uncertain, complex, and ambiguous world. The scope includes many things. It goes from helping preserve the meaning of agricultural data to sustainability metrics, to managing crop systems for all kinds of crops of food, fiber, energy, etc. Integrated pest management, which is a big problem worldwide, dealing with livestock and integrating livestock and cropping systems, and so forth. Our geographic footprint is pretty big. We've got participation from multiple countries. About 45 right now. There are gaps. There's regions that are woefully underrepresented, but we're actively working on stakeholder engagement. And this technical committee, by the way, I mentioned that we've had two plenary meetings of all the members so far. The first one was on April 10th. So we've been up and running for about 7 months and a half or so, not too much. The strategic roadmap is sort of something like this, where you've got a horizon model of what we want to do in a hurry, and further out, we've got a series of themes like internal coordination, external coordination, some sort of low-hanging fruit data standards, and communications, of course, because unfortunately standards tend to be well-kept secrets, because all us geeks tend to be exhausted when we finish the standard, but really don't pay as much attention as we should to communicating the value and the existence and how to use the standard to professionals out there, right? So we focused on a series of critical first steps. We're increasingly connected to other organizations, interoperability groups like the Ag Electronics Foundation, Ag Gateway, GS1, the Open Geospatial Consortium, and so forth. And although we're quite young, we've got a lot of things going on, right? In addition to communications and stakeholder engagement and an effort that's beginning on responsible innovation. We are already working on things like integrated pest management, greenhouse and controlled environment automation, and agri-semantics. So standardizing what we mean by the ideas of crops and pests and active ingredients and modes of action and things like that. So this list of things that we're doing is growing quickly. People are quite engaged. We have well over 200 experts at this time involved. I mentioned some of the early work streams, echoing them here. Fall armyworm is where we've got our first emphasis in integrated pest management. These are some of the agri-semantics things I mentioned as well, which brings me to International Workshop Agreement 47 that Derek had mentioned. If you're going to walk away with anything about that, I think this picture says it. The landscape of agri-food systems data interoperability is very messy and full of garbage. What this IWA is meant to do, sort of clear the way for the fancier Technical Committee 347 bus that comes after it. In a nutshell, it's a very agile and inclusive mechanism to provide CC 347 with the start of what's called a reference architecture for data-driven agri-food systems. It's producing a set of terms and definitions, a thing called the capability model. It would serve as a sort of map of the kingdom, a set of use cases that we can use to kind of anchor our standards to, and so forth. Very, very helpful things. It's also inclusive in that it has a very low administrative burden to participation. That's allowed us to get people from different countries that aren't participating in Technical Committee 347 to be participants here and see how this thing works and what's in it for them. What's a reference architecture? Well, an architecture is the way you build something, right? An architecture description in ISO speak is a document that explains the architecture of something. So it explains how to build something, right? So it's like the blueprint. So that's the architecture. What's a reference architecture? That's a set of general guidelines or best practices to use when you're creating an architecture. So it's a sort of a blueprint for how to make descriptions for certain kinds of architectures. So if an architecture has a description, a reference architecture has a description. And that's what IWA 47 is about. taking the first steps towards a reference architecture description for data and software in agri-food systems. And this involves things that are pretty straightforward, like defining terms, or like using domain knowledge to describe use cases. And it involves increasingly geeky things like talking about interfaces and data models and whatnot. IWA 47 is just the start of this reference architecture work. So its 3 primary deliverables are use cases, a capability model in terms and definitions, which TC 347 will make standards with and maintain, but we imagine multiple other committees within the Smart Farming Coordination Committee of ISO will also use. This slide is just a very sort of quick way of saying that the use cases encompass the answers to the basic who, what, when, where, how, and why questions of when you're analyzing a system within the agri-food systems domain. But then there's also how ISO and the standardization domain works, which has its own set of actors and processes and who, what, when, where, how, and why. And that a concept called business capabilities, which are sort of the basic units of what is done in a domain or what an organization does as a way of doing business. These capabilities sort of help us bridge the distance between the artifacts of these systems, like standards, and the use cases. So now I get to the most important 2 slides of this presentation. The first one is, why would you care about all of this? The first reason is because participating in this is possible. You can participate in the system, and it will give you the opportunity to help build the world that you want to live in, right? The way that these standards always play out is that the decisions are made by the people that are sitting around the table. You can sit around that table and help make a better world, especially one that's more food secure and just. You can also acquire leadership experience and learn to do more cat herding in an international context, learn to build consensus and get things done with limited time and resources. Very hands-on project and product management skills. Also learn business strategy skills, other business skills, systems thinking, and management systems thinking, as well as information architecture in our technical committee. Also, I can't stress this enough, the value of the networking experience from participating in these things can be huge. Maybe your advisor in grad school loves you and is super important, and their word will open any door, but maybe not. And there's some really important industry professionals that participate in these things that know a lot of people. Recommendations from them can also produce great opportunities. And also the diplomacy experience that you can get from working in an ISO technical committee is very non-trivial. You get to interact with colleagues from the EU, from China, from Iran, from all these different places that you wouldn't get the opportunity necessarily to do in other contexts, right? And not only that, but you can leverage your young person technological advantage to really make a difference in the standard space. So what do I want from you? Consider getting a taste of the system by joining IWA 47, which is free. You don't have to pay anything to participate, but it's going to end soon. And I'm going to put the link to it in a moment in the chat. Also, we'd love for you to join TC 347 if you want, but we're also creating a youth leadership group linked to TC 347 in the way that, for example, the Environmental Management Technical Committee, our sister committee for environmental management in ISO is doing, which is a very good model. That may be a better or more efficient starting point for you. We're going to have a meeting in early January to discuss the organization, like saying, how do we do this? What would this program look like? How many young people can participate for how long? What would the goals be? What can we expect? You know, would we have real world experiences? Is there a mentoring component? Hint, yes. What kinds of opportunities will we get to participate in, and so forth? How would people be selected? What would the guiding principles and governance be like? And so forth, right? And so we're going to have a meeting in January to work that out. And we would be very interested in hearing from you and having you participate. We'll have young professionals from other parts of the world as well. I think one of the fundamental ideas is that we want to have this be open and have good governance that everybody can participate in. So your voice will be heard and will be relevant, right? So please follow our LinkedIn page and stay tuned for details, and feel free to email and connect with me. Okay, so with that, thank you very much. This is the same barcode we had a moment ago. So I know we have maybe 12 or 13 minutes for questions.
Thank you very much for the session. I think that was really great. We have learned a lot from the sessions. So we can, I mean, if you have questions, you can signify by just raising your hands. I mean, just use the icon to raise your hand, or you can also drop the questions in the chat. So I believe there will be a lot of questions we'll probably have about what he has shared. Let's drop that in the chat. Okay, while we wait for people to drop their question, I wanted to ask about the phone app you showed earlier. Are those free to use, and do you ever worry about the accuracy of what they provide?
That one in particular had a great accuracy, very good. We within Syngenta, there was quite a bit of effort that was expended into testing it, right? Because not all apps are created equal. We were careful in developing that app, in that we followed what I consider sort of a three-stage model, where first you try to simplify the problem, try to reduce the size of the problem, doing things like, say, in the case of a stand counter with your phone, forcing the user to keep the phone horizontal, right? So that you don't have to deal with parallax and panoramic distortions and things like that. That makes the problem a lot easier. Then you go solve the machine learning problems, which in this case, there was an object detection one, and there was another different kind of density estimation problem. And then you contextualize the result, which in the case of this meant things like trying to ensure that the canopy wasn't too closed so that you could make sense of the results and so forth. I haven't been in touch with that program for a couple of years, so I don't know if Syngenta is making that free now or not. I'm sorry, I don't know the answer to that.
Okay, yeah. So one other question I have is, so currently we have a lot of young professionals on this page, But the challenge is some of them probably don't have a lot of background in heavy data, IoT, AI, things like that. So maybe this is a new terrain for them. So how would you kind of encourage them to see that this is not necessarily something you can do? You can still do it, regardless of your background.
That is a very good point. And in IWA 47 and in TC 347, we have a very good mix of skills. In general, you need very few of the very specific data modeling skill set people, right? You need a lot more of people who understand the domain, right? Or who understand the needs of their community, or who are interested in learning how to learn the needs of the community, right? That can do the stakeholder engagement, that can do the posing of problems, that can think about how to simplify the problems. So the actual data modelers that you need aren't very many, right? Because they sort of inherit the problem once it's been chewed on by people that are closer to the domain. So I would not let the lack of formal, say, data science or data modeling experience deter you at all, right? It's not hard to learn some information modeling from books or from other people. It's a lot harder to learn what life in a village in a certain area is like when what you come from is an engineering, or data modeling background. So what you know about your community is very valuable here, right? Regardless of whether you were born in the US Midwest and the Cerrado of Brazil, in Western Nigeria, or where, right? Any other questions? Let's see, I have. Okay. Little private note there. Yes.
Yes, Dr. Ferreyra, thank you so much for the presentation. And I wanted to ask about since we have the small scale farmers as part of the whole system, how do you think the policymakers or the government can incentivize data collection, especially for the farmers at the small scale? And my second question is currently based on the system dynamics, I think Africa, I believe, I don't have data to back that, but I believe Africa is underrepresented. So how can it be a global something with all the intricacies or all the nuances that happen at the Africa farming business scale to be incorporated into this bigger system? So
Sure.
small scale farmers and African network. Thank you.
Okay, my brain is full, so let me try to answer the things that I held on to. So first, you asked about how governments and policy can help move this forward, right? First, I think it's important to say that I'm noticing that governments worldwide maybe be driven by a lack of resources, too much to do, or a growing understanding that it's better to work together than to just reinvent the wheel, are showing increased willingness to look at and participate in international standards as a way to move forward, right? So in situations where typically you'd expect governments would just go and make their own stuff up, I'm seeing that governments are taking a keen interest in standardization efforts. And I think that is a wonderful thing. We've got we've got folks from governments and regulatory agencies quite well represented in our committee. And I think that's great because, and now we move on to the second question, but linking the two. When governments understand the value of these standards, they also understand the value of investing in the kind of infrastructure that helps you deploy solutions based on those standards. These are the sorts of things that India has been doing for e-commerce for quite some time, not specifically for agriculture, but for e-commerce in general, where there's this infrastructure in the cloud that people can use that's based on standards that makes it possible for people to solve problems for a given community, making rather skinny apps that aren't reinventing the wheel, that aren't reinventing the infrastructure. They're just using what is already there and doing so with ease because the infrastructure is standardized, right? So in the case of Africa, I think that the global investment that's being made here in standardizing some fundamental capabilities of data-driven agri-food systems can be used very advantageously by technologists in Africa to create solutions for their own problems and also as tools for revenue creation in an international market because they can focus on the problems that they know how to solve, like the agronomic problems or the business problems for that area, while leveraging the existing infrastructure that emerges from the standards. And our group is very cognizant that we have underrepresentation there. We have spent quite a bit of effort in 2024 trying to expand our presence in Africa, and that will only just continue and grow. And recently, at the conference of the Asia Pacific Federation of Information Technologies and Agriculture in Tsukuba in Japan a couple of weeks ago, we extended that stakeholder engagement effort to Southeast Asia. So that is an ongoing effort, limited by just the people that show up at the table to move those things along, right?
Thank you so much. That's it.
Have time for one more question, maybe?
One more. Yeah. Do we have anyone with question? Okay. Ashmita has a question in the chat. Okay, you can. You want to ask, or we can read that out as well. So thank you for the presentation. I'm reading from Nepal. I'm Ph.D. in Kansas State. Regarding my involvement in the workshop, do you expect me to represent the agricultural system here in Kansas or back in my home country?
I want you to do whatever is most valuable to you, right? These sorts of international efforts are predicated on the idea that people show up because it's valuable to them. So I'm not going to ask you to do something that isn't in your best interest, right? So whatever you think is most valuable there, go ahead and pursue it. Now, within our youth leadership group that we're going to be setting up in the relatively short term, we're going to look for sort of a battery of real world problems that can help sort of move the ball and come up with some solutions and ideas that can be helpful to the participants and to their environment and to the industry as a whole, while at the same time building skills. You'll have input on what kinds of exercises we can select and what data sets we use and so forth. Thank you for that question. That's a very good one.
All right. Well, I'm not sure if anyone has any last minute question, but We're right on time now. It's 2 p.m. already. That's 3 p.m. Eastern and 2 p.m. Central. So we really want to appreciate you, Andres. Thank you so much for coming to share with young professionals today. Personally, I mean, I've learned a lot and I'm still learning. And I know a couple of people will probably join the workshop session. We'll share the link as well. Please check the chat box if you want to sign up for the workshop. That would be great. Would also ensure to share that link also with all the young professionals so that they could be part of it. Once again, we appreciate you. Thank you for joining us today.
Thank you all. Have an excellent rest of your day, and thank you very much.
Thank you.